Hey everybody, this is Mr. Kinney. We're going to do our notes now on balancing equations, and there's a fair amount of them here. And for my substitute, when I ask you to pause the video, please hit the enter button. That'll momentarily pause it. So to begin with, everyone, we're going to title this Conservation of Matter. That's the part A underneath this. And conservation means keeping or saving. Matter is the stuff that the universe is made out of. And the first rule under the conservation of matter law is number one: matter cannot be created nor destroyed. So if you could hit the enter button for a moment to my sub, I'd appreciate that. Give them a chance to get that written. Number two underneath this, underneath the conservation of matter, is that matter can be rearranged. So you can't create or destroy it, but it can be rearranged. And that's what happens in chemical reactions. You start with some stuff, and then it breaks apart, gets torn apart, gets added together, and it makes something new. So if you need to, go ahead and hit the enter button until I get that. Number three, under the law of conservation of matter. In a chemical reaction, you end with the same number of atoms, and actually the same atoms as you started with, but they'll be in different molecules. Or sometimes the molecules might break apart and they're going to be just elemental forms. But the main thing here is you're going to start with one set of chemicals or elements, and then you're going to end up with the different. So go ahead and pause that until the students Okay, we're going to move on now. The next thing, part B. Part B, writing chemical equations. And while you're writing that term, do not write this paragraph. Do not write this. Okay? Chemists are lazy. They do not want to spend a lot of time writing out anything more than they have to. For example, two hydrogen gas molecules mixed with an oxygen gas molecule, then exposed to heat energy, will chemically rearrange to form two molecules of the chemical water. Now, chemists do not want to write all that out. That's why they first off invented symbols and such. So, let's make it easier. They're going to write it like this. Let me zoom out there. So there's our two hydrogen gas. We start two hydrogen gas molecules, two H2s. And let's write the gas in there. We got one molecule of O2 as a gas. And then that's going to change into two molecules of water, H2O, as a liquid. So if you need to pause that, go ahead and hit the enter button. Oh, there's a visual too it goes with it. You don't have to draw the visuals, but it was just to let you see we've got four hydrogens, 4 hydrogens, two oxygens, we end up with two oxygens. This is a balanced equation that I mentioned before. Okay, Now, continuing on with this, let me come over here. So, we're going to call this number one, coefficients and subscripts. You can this is the one we had before. You can leave that on there. And what I'd like you to do is to label what you did before. That this number here, the 2, the number in front is a coefficient and it's a multiplier. It tells you how many of the molecules we have. The letter written lower here, it's called a subscript. And what it does, it just tells you how many of the atom in front that you have. And then I'll scoot down. We'll pause here in a moment. The chemicals that you begin with, they are called the reactants. They're reacting together. We've got the chemical change arrow. That means a chemical change is occurring. And then what is produced are called products. So if you need to pause at this point, this would be a good time to hit the enter button. So continuing on now, we're going to head on through here. Continuing on with coefficients and subscripts, Here's some rules about those. Number one, you may change the coefficient, but not the subscript. So when you have, in our previous problem up there, we had like H2. Now, when you're trying to balance an equation, you cannot say, oh, I need 2 more hydrogens. I'm just going to change this to make it H4. You cannot do that. The element, the molecule hydrogen is H2. If you need 2 more, you may put a coefficient up here to get it balanced out. But you may never, ever change a subscript. And let's take a look at this equation right here. Now, I'll burn this for you. It's really cool. This is a metal that can burn, but I can't do it right now. So let's do Mg plus O2 gas changes into MgO, magnesium oxide. Now, this is not a balanced equation. Problem is, we've got, and here's how you work out balancing an equation. Okay, we got 1 magnesium are okay here. We have 2 oxygen atoms. We need 2 oxygen atoms here. And you may not put a 2 there. That is a different compound than magnesium oxide. You may, however, put a coefficient 2 in front of it. Oh, okay, let's see. Not enough O's. Yeah, we know that. There we go. That's just what I did. So we got the coefficient 2 put on there. Now let's see, is this balanced? 2 magnesiums? Oh, wait a minute. Sorry, I got ahead. When I put this coefficient 2 in front of here, the oxygens, there's now 2, but look, we've got 2 magnesiums, so we need to come back and we need to put a coefficient 2 in front of the magnesiums. Now I think we've got it balanced. 2 magnesium atoms will react with 1 molecule of oxygen, and it'll produce 2 molecules of magnesium oxide. So this is now a balanced equation because we have the same number of atoms on both sides. We can add those up if we need to. We got 2 magnesiums, 2 oxygens, 4 atoms over here. We have 2 magnesiums, that's 2 atoms, plus 2 atoms of oxygen in this 1 molecule. Okay, we have 4 atoms. Moving right along here. If you need to pause, go for it. You can hit the enter button, but we're going on. So, number 2 now, writing chemical equations. Let me get this so we're not getting too much here to start with. So let's see, first off we got the reactants. Those are the chemicals you mix together in the beginning of the reaction. They're on the left side of the equation. Number 2. And hey, maybe if they need to pause, you can go for it. So go ahead and pause. Part 2, chemical. The arrow just means the atoms are rearranging to make new chemicals. This is just a shortcut to say we got a chemical change occurring. And then lastly, the products. We've labeled it before, but these are the new chemicals produced in the reaction. They're on the right side. Everybody a chance to write that down if they need to. Now let's see, what do we got next over here? Well, let's see, we've got, I think we're ready. Let's see now, going on here. So for the previous problem that we had, let's rewrite the equation. We had 2 magnesiums plus 1 oxygen gas molecule, and it'll rearrange to form 2 atoms of magnesium oxide. That's what we just wrote before. So working on this, we've got a coefficient 2. In fact, there we go. These are subscripts. So we just got to make sure you need to know the difference between a coefficient, the multiplier, and then the subscript that is telling you how many atoms there are of that element in there. So let's do a practice problem here. So I'm just kind of looking ahead here what I want to do on this. Burning hydrogen gas. So this will be an example here. I'd like you to write this down. This is what we would call the skeletal equation, meaning it hasn't been balanced yet. So go ahead, hit enter, sub, and let them get that written. And taking a look at that, we can tell, all right, let's start here. 2 hydrogens, everything's good. Over here in the reactants, 2 oxygens, whoop, we only have 1 oxygen. So what we need to do, the oxygens do not balance. You don't need to write that out, I'm just going through a process here. So what we need to do is we need to add a coefficient 2 over there. So don't rewrite all this, just put a coefficient 2 up there where we started. So now we've got 2 H2Os. And let's see, altogether 2 times 2 hydrogens is going to be 4 hydrogens. So it has to happen, we need to put, let's see, we had that there. We're going to need to put a coefficient 2 in front of that hydrogen up there. So now we have 4 hydrogens there. We have 2 oxygen atoms, and we have 1 times 2 oxygen atoms there. We are balanced. We got a balanced equation. Same numbers of everything on each side. So that's the process you go through. So I'm going to give you, let's see, 1, 2, 3, 4, 5 practice problems to do while we're waiting. So let me substitute, if you would please hit the enter button and give them time to get those equations written. And again, we're leaving room for the coefficients. Well, I'm going to go through now, and you should have had time to get those written. If you didn't, you can fill them in as we go. So what I like to do is when we start balancing equations, let's just see here. We got 1 zinc, 2 oxygens, whoop, only 1 oxygen over here. So we can put a coefficient 2. Oh, wait, you know what? I'm just breaking the golden rule of balancing equations. Use a pencil because you will make mistakes. Hopefully I didn't totally goof this one up. All right, putting that away. So we're going to put the coefficient 2 over here, which means now we have 2 oxygens, because if we do the subscript 1 times 2, 2 oxygens. We have 2 zincs. Okay, so over here I'd need to put 2 zincs over there. And I think right now, I think we're balanced. Now chemists won't usually put a coefficient 1 in front if there's just one of them, but I'll just do it here just as we're practicing. So 2 oxygen atoms, 1 times 2 oxygen atoms. The oxygens check. 2 zincs, they check. There we go. Okay, the next one right here, hydrogen iodide breaking down into hydrogen gas and iodine gas. Well, we have 2 hydrogens, so, well, we're going to have to, only way we can add more hydrogens here, let's put a 2 over here. So now we have 2 hydrogens, we're good. Now this means we have 2 iodines now. Oh, look at there, we have 2 iodines. So we could put a coefficient 1 in front of those. This is now a balanced equation. Because we have 2 hydrogens on each side, we have 2 iodines on each side, we're done. Okay, we've got boron plus F2, fluorine gas, changing into bromine trifluoride. So now what we've got here, let's see, we got 1 bromine, 1 bromine. Oh, now we got a weird thing. We got 2 fluorines and we have 3 over here. So this is where you need to use the least common multiplier, or multiple. And the number that goes into both 2 and 3 evenly is going to be 6. So what we need to do is 3 times what is 6? Yeah, you're right. 2. So we're going to put a coefficient 2 there. And 2 times what is 6? Yeah, you got it. It's 3. So let's see here. Oh, now we've got, now I'm taking a look at this. 3 times 2 is 6 fluorines. 2 times 3 is 6 fluorines. We're looking good so far. The borons don't match. Look, we got 2 borons here. We only have 1 boron there. Okay, well, for this reaction to occur, you'd have to have 2 atoms of boron plus 3 molecules of fluorine gas reacting to make 2 molecules of bromine trifluoride. Well, let's see. Let's take nitrogen gas, which is very common in the atmosphere, mix it with some hydrogen. And I believe they call this the Haber process. A German gentleman, maybe Austrian, figured this out just before World War II. And it'll produce ammonia. That's ammonia over there, NH3. So let's see what we got here. Now we got another one of those things here. When I'm looking at this, first off, what catches my eye is I'm going to do the hydrogens here. So we've got a 2 and a 3, so we got to do the least common multiple again, and that's going to be 6. So 3 times what is 6? It's going to be 2. 2 times what is 6? 3. So now we got 6 hydrogens. 2 times 3 is 6 hydrogens. We've got 2 nitrogens here. Oh, look at there. 2 nitrogens. Just put a coefficient 1 in front. This is now balanced. 2 nitrogens, 2 nitrogens. 6 hydrogens. 2 times 3 is 6 hydrogens. It is a balanced equation. Okay, this one right here. Oh, let me scoot that over if you didn't get that over there. Well, heck. What I'm going to recommend now, here's what you do. We could start to balance the iron here, but since it's all by itself, I recommend leave that one alone till later. Let's work with balancing, let's try balancing these oxygens first, because I see we only have 1 oxygen over here. There's 4 over there. So now, again, with the pencil, because we might have to erase these, okay? So let's try it. Let's put 4 over here. We've now got 4 oxygens. We've got 4 oxygens. Okay. And let's see, do this one last. Let's see, now we've got 4 times 2 is 8 hydrogens. Well, that's easy to fix. We can just put 4 times 2 is 8 hydrogens. So now, let's see, we're all balanced for the oxygen to hydrogens. We got 3 irons here. We just have to put 3 irons there. We can put a coefficient 1 there. Now let's make sure it works now. 3 irons, 3 irons. The irons are balanced. 4 times 2 is 8 hydrogens. 4 times 2 is 8 hydrogens. We have balanced the hydrogens. And if you want to have that subscript 1 underneath there, 1 times 4 is 4 oxygens. 1 times 4 is 4 oxygens. So this is a balanced equation. We have not created or destroyed any atoms. They have just rearranged in there. And so hopefully you've got that one there. So I think what might be a good thing now, because I have more notes, but I don't want, I'll have you come back to those in a little bit. I am going to have you take a little break right now and work on this paper, the Balancing Equations Challenge. And it starts off by asking you some questions here. So you work together on those. Now, I want you working together on these, okay, and get these all filled out with what these things are here, okay, and so you can look back in your notes. Oh, look at there. Oh, it's fill in the blank. How easy is that? How easy is that? Okay, wait a minute. Okay, let me just take a look here. Yeah, okay, that one's okay. Hey, this one here, just so you know, in case, this is hydrogen peroxide. Some people use it to mouthwash. Some people use it to disinfect. And I guess you can, I don't know. Anyway, that's hydrogen peroxide. Okay, no, nothing major there. Oh, wow, already did that one. Okay, whoa, that's an interesting one. You don't see that every day. And, oh, this is methane gas. That's what you get when you have too many beans. This is rust right there. Okay, let's see. Oh, there's a fuel. Okay, so I'm going to have you work on practicing balancing these with your partners. And I'm figuring I'm going to give you and your partners about, I'm going to ask the substitute to time this for about, I think about 10 minutes should be about right. So with that, I'll let you get to it, and we'll end this here. Good day.